Hey, hi everyone. Welcome to our August office hours. Um, First, we have a couple of updates on the Altinity side, and then we're going to dive into questions. This should be a pretty quick one. We got a lot of other things going on, lots of opportunities to connect with us on Project Antalya and all of the other things that we're working on this month. So first, we have share. So we have this webinar coming up next week. On actually a week from today, a little bit earlier than this time. And this should be a really great series, especially for anyone who's managing ClickHouse instances that other people are using. If you're trying to use ClickHouse as a developer, just as part of your application, you might want to check out the webinar that we did last month that was more from the developer's point of view. This was going to be all about administering ClickHouse, and it should be like packed full of valuable information. I know I had multiple pages of notes from last month's webinar. Robert shares so much good information. So that's coming up. We are also starting a new podcast series next week that will be recording on Tuesday if you'd like to join us for the live recording of that. And then we have some really good stuff going on with Project Antalya. Alexander, maybe I'll let you talk more about each one of these bullets if there's more to say, but the bullets that I have is that we've got loading data into Iceberg using the ice command. I'm curious if anyone on this call has tried that out and wants to talk about that. We're starting to look at S3 table buckets and making sure that that's tested and fully supported. And then maybe you can share a little bit with us, Robert and Alexander, about what's coming up in the next release. I think later this month, right?
Yep.
Cool.
Thank you, Josh.
Hey,
Yeah.
hey, Alexander, do you want to see the picture, the little picture that we tweaked together to show people what's going? So where do you want to start with? Here, I'll just share my screen and then you can decide which one you want. Uh, no expense was spared in this high quality presentation. Let's see. Do you guys are you able to see it? I can't see what I'm
Yes,
sharing.
yes, this looks great.
Okay, great. So this was something that was loading data with ICE, which actually I'm writing a blog article on, but it's not done. I'm just going to just give some background on this. And Alexander, I'm sure you can show in color commentary, and then you can do, then S3 tables is your baby. So ICE is, for those of you who don't know it, it's a catalog that we developed to serve as to help us build data lakes inside of Altinity.cloud. And the reason we did that is that there are lots of catalogs out there, but it turns out that having one that is really super simple, first of all, super simple, can start just as a single line command and run anywhere, literally from, it can run, like as a process on your desktop, or your laptop, all the way to inside a CI/CD pipeline, all the way to inside a Kubernetes cluster at scale. We didn't find that something that was really handy, so we went ahead and wrote it ourselves. We didn't actually write that much because it's a wrapper over the Java libraries that are provided, the Java REST API, which is kind of the, if you will, the reference implementation for working with REST from client languages. So, so you have the catalog, and then the ICE command. So that if you go in and look at the examples in the ICE project, you'll see the ICE catalog. You'll also see the ICE command. The thing I wanted to talk about a little bit was the ICE command, because that's the other half of what we do with this project, was we make it easy to load data. And this is an example of what the commands look like. I'm doing this in basically in Kubernetes. So the stuff that you're looking at here, the first 10 words or so, are just getting us into a Kubernetes pod so that we can run an ICE command. The business end of this is ICE insert. And this is a command from the command line that, as long as you have parameters set up to connect to the catalog, and they go in a little YAML file, you can then just go ahead and insert data into files or into tables in S3, and you just you say ICE insert, you give it the name of the table, you give it the bucket where the data is going to get read from, and the ice command will go ahead and find those files in the bucket, and then it will load them up for you. So what I wanted to talk about just briefly was some of the options that are available, because this is a really important to be able to load data efficiently so that it can be seen by ClickHouse. So I highlighted this option called S3 copy object. Pretend for 1 second that that command is not there, or that option is not there. What ICE does is it will go find the file, and then it will basically force uh, a copy that streams down through your client and pushes it back up to S3. So this is actually pretty slow, because it means that the files are going to have to flow through wherever this command is running and then get pushed back up to S3 again. For anybody who's worked with S3, you know that that's super slow. What you'd really like to do is, if you have files in one S3 bucket and you're moving them somewhere else, like within that bucket or within another bucket in the same region, it would be really nice to just copy them in the background. And that is what this S3 copy option does. So, or a copy object. So if you can just get your data into S3 somewhere, this S3 copy object, if it's possible to do so, will go ahead and do a background copy. This is really fast. It makes the difference between things that, data loads that run in hours to something that runs in a few minutes, because it's basically just telling S3, hey, I need a copy of this file in another location. And S3 has some backend magic where it basically, I assume because of the speed, it just swizzles some metadata that's basically, so you've got two people pointing to the same patch of storage, and then they do some copy on write magic. Your file gets moved, but it's hidden to you and it's fast. So this is a really important option when you're loading data into S3. Another thing that makes this even better is, since the actual copy option doesn't put any load on your system, or where you're running, you want to run a bunch of these copies simultaneously, and that's what this thread count does. So you can set this value up, and the load that you're going to see on your client when you're moving these files in is very low. So set it up to 10, 20, whatever. That makes it move extremely fast. So
And
this is,
Robert,
yeah,
quick
yeah.
question. Will those threads will also run on Swarm nodes if I have those available?
Actually, what they will do, this is all a really great question. This is actually running on the VM that this command is running on. It doesn't use the Swarm, not yet.
Got it. Okay.
We are working on enabling the swarms to load the files, but we don't have that yet. One of the reasons we're doing this S3 copy object is it makes the swarm unnecessary, because there is a swarm, but it's actually owned by Amazon and it's hidden somewhere in S3. So they've already solved that problem for us. So that copy in background is a really important option. There's another one though that you might want to do, which is you might want to load data into Iceberg, and these are Parquet files. They're stored on S3. Iceberg manages them. You might not want to copy them at all. You might want to just swizzle them to, you might just want to have, excuse me, not swizzle them, but you might want to have Iceberg just take them in their current location. That's even faster because we don't do anything. So there's this no copy says, hey, this file is, take these files when you find them and just register them in Iceberg. So they'll be added to the metadata, but there's no file movement. This is the quickest of all, except that it doesn't always work, because Iceberg expects these files to be in a certain location. Conventionally, if you look at the paths in Iceberg, for an Iceberg table, there's a metadata path that contains all the metadata information about the table, and that tells clients, hey, here's the table, here's the files that currently belong to that table, so on and so forth. And then there's a data path. And so Iceberg kind of expects to see the files there. If they aren't, you can still force it to accept them, and that will work. One thing I should add is S3 copy object has a size limitation. I believe it's around 5 gigs. And it doesn't, Alexander, I don't think I haven't found a way around that to change that. I think that's a limitation. So that's one where you do end up. So if your Parquet files are really big, you end up having to use either the snow copy or just back off and copy everything. That's it for loading loading files. We're doing a lot of this, and so I have a blog article I'm working on that will just talk about loading large amounts of data, and this will also talk about a new feature that we're adding for loading files, which we'll talk about in a minute when we get to new features.
So can I ask a
Yeah.
question?
Oh yeah, go for it.
Yes, please.
I'm new to this. The Iceberg is a lot to learn, right?
Yeah.
Yeah, a lot to learn. I'm very confused between catalog here and there. But
Yeah.
my workflow is this. I want to move the data from hot to cold, which is Iceberg S3, right?
Yeah.
Currently we don't have the TTL to do so, but this is okay. I can use the ClickHouse client to export the data. But then how do I load it to S3 and Iceberg?
Yeah. So
I don't have
yeah.
the instruction. So
That
if you do this, right, IT catalog, I understand the insert. Does it mean we taking the data from the local drive somewhere and put it in S3 and somehow it get loaded to the ICE catalogs?
where is okay, so where is your okay, so here's basically so the problem that you've stated is you have data in MergeTree files in
Yeah,
ClickHouse. What you want to do is export them out and put them into Iceberg for long-term
correct.
storage.
Long
Yeah, okay. Basically, the way that this works is you're going to take the MergeTree data, the parts, for example, that you want to move, and you will convert them to Parquet and put them out on S3, just any path you want. And then you can do, say you generate 100 of these files because you want to do this in big batches. And then the next thing you do is once those files are out on S3, you'll go ahead and run a command like this one that I'm showing, this ice insert command, point to that path, give a nice star here so that it will just collect all the files, and then you just let ice loose and it'll go ahead and load the files
Oh,
for
so
you.
it load data from S3 into the ICE catalog.
Yeah,
And
exactly.
assuming it doesn't do duplicate.
Yeah.
Yeah, okay.
Yeah. So what we are working on, and this blog article I'm writing will explain that exactly that procedure. What we're
Mhm.
working on right now, as hard as we can, is to make that automated, to put what amounts to a TTL.
Yeah.
So we have those tables in design. This is everybody wants this, us included. So the idea will be that you will have a way of defining taking existing merge tree tables and putting a TTL on them or something like a TTL, which will it might and we're still working on the syntax. It might be something like TTL export, where it will just automatically take the data out and push it into MergeTree. Not only that, or excuse me, into Iceberg. Not only that, it will remember which data has been pushed to Iceberg, and so when you run queries, we're adding and we're working we're working on a feature that keeps track of which data belongs to MergeTree, which data belongs to Iceberg, and then your queries will automatically get directed to the right location. So you can run a table on this entire a query on this entire extended table, and it will go ahead uh, and break that query up, send one part to MergeTree, one part to Iceberg, and you get your results back.
Can I ask another question? It just maybe
Yeah.
a few more minutes. So the use case in my side is that we are dealing with 1.5 or more millions transaction per second, and each transaction is about 1K, right? Sometimes it depends. If you have a football game or Canadians hockey, then it can go more, and it can go down, up and down. So some of the customers, like they really want to keep the summary data, like for 3 years. I don't know why, but that's a requirement. So now we are doing with multi-tenancy, meaning the CDN, the top guy can sell data, can sell services to a lot of smaller guy. So this amount of data, if we have to use, Amazon EBS, it's not going to, we won't survive. So this is what I am thinking. I'm not sure I'm in the right directions, but we only keeps data that we need to troubleshoot for maybe a week or two. Anything else we move to Iceberg, right?
Yeah.
That's
Yep.
where I'm coming from. You know what I mean? And a lot of data, though.
Yeah, you're I you're thinking about this the right way. Or let's put it this way. You're thinking about it the same way that we're thinking about it, which means I hope I hope we're both right. So here's what we're designing. All right, here's coming straight out of the lab. This is very fresh. I make no representations. This is actually what it's going to look like. But the design is basically to build a new kind of table type, and we have this kind of provisional name for it. It's called an infinity table. I'd be very interested in how you guys like that name but the notion is you have that data which is, sort of loaded in and kind of hot, lives in MergeTree, and then you want to keep it, sort of like for your 3 years out on Iceberg on cold storage. And so the infinity table, the idea is to take it's a way of taking any existing MergeTree data and just extending it to infinite length, but having reasonable cost and having a system that's manageable. So the basic idea is that we're working on is you can think of the table as consisting of segments. So there's your hot data, and that would go, when you insert to this table, it would be put into MergeTree as it usually does. And then there's your archive segment. That's the data that lives out in Iceberg. And then there's an export process that moves it between them. So it's like a TTL, but the difference here is that, well, actually the difference is there's no difference here, because with TTLs, that TTL process typically runs once a day. And so we would do a similar thing is, at the end of some time period, we'll take entire partitions and we'll just move them lock, stock, and barrel over to Iceberg, and then we will update this watermark to say, hey, the default, the data time has moved forward. Now, when you look at this particular partition, go look for it in Iceberg instead of MergeTree.
Now, this is more flexible than TTL, because my experience with TTL, when you change it, it's not that make change to the TTL statement. It takes some time.
What is it? Yeah, it would be very interesting to know what problems you see, specifically so how do you mean it takes time? If you could describe the issues you've had with TTLs.
That was a while ago. That was a few years when we used TTLs to move data.
Yeah.
And that early, and something about it, we have to roll back. We have to delete every single TTL in every single table. Something that it caused merging it extremely low. We have to roll back everything, the whole implementation.
I think this is materialization. So
Yeah. Something that back then, I don't know, but we haven't put it back then. We have to put it back in. We have to do manual drop partitions. For example, the raw is, you don't want to store, 1 million per second for more than 7 days, right? So we drop partition daily manually. But back then we found that, there's a TTL to do that. And we put it in. Oh my God, it just like took the production things like a while.
I have a feeling that might have been a case we helped you with.
Yeah, things are a bit better since then. You have control about what to do when you add TTL. So it's not a big problem anymore.
Right.
But in case with Infinity tables, so we initially at least give user full control with very little automation. So, and one of the reasons is that, as Oliver asked, the data will be duplicated always at some amount of time. When you export data from your default segment to archive segment, of course there will be duplicate for some time. But the queries will not see this duplicate because we move the watermark. So they will see consistent data, and later we will delete this data from the default segment automatically or semi-automatically. So we in ClickHouse, in MergeTree, the consistency is very important, and there is a lot of logic to make sure that the data is consistent when mutations are done, when moves are done, and so on and so forth. With Infinity tables and archive segment, we cannot guarantee this consistency because these are two different distributed systems, but instead we can guarantee that the watermark is correct. It is much simpler task to solve.
Yeah.
Yeah.
I understood that time.
Yeah.
So it wasn't bad.
Yeah, well, so what I think we'll do, Sasha, one thing we could do is sort of well, certainly once we've got a couple of the pieces of this that are coming out. First of all, the ability to generate these parts. There's an alter table export command that we're working on. That this is getting into we promised we'd talk about future stuff. This is a really key one. One of our guys is working on that pretty hard right now. In fact, this design here is to help figure, ensure we've got the requirements and the specification right. The other thing is then being able to vacuum them up into, once these things are exported out to S3, we'll be able to vacuum them up into and put them in the right place. Flip it back to the picture of ClickHouse S3 tables if you want to talk to that, or if you want to do a demo, however you want to proceed.
I think I trained you to make a demo, but I can do it as well. So let me explain what we're doing here. Have you guys heard about S3 table buckets? Not S3 tables. I think it's correct naming as S3 table buckets. This is a new service that AWS launched in December last year, and this is a combination. So they position it as adopting S3 for analytics, and they do it in pretty interesting way. So this is actually a combination of S3 as a storage and the Iceberg catalog as a service baked into this S3 table bucket envelope. And amongst the other things, it gives a lot of functionality that production-ready catalogs typically provide. For example, if you're familiar with Iceberg in general, right? Iceberg catalog is just a catalog. It's not database management system. So what it allows you is to see the data and to get meta information about where the data is located, and then use a query engine to query this data. But it's pretty straightforward. ClickHouse can do it, Trina can do it, Spark can do it, a lot of different systems can do it. They use the information from the catalog, but the query engine is outside of catalog. Things get worse when you want to insert the data. Again, catalog is not DBMS. You cannot insert into a catalog. You need to insert the data first into the object storage, and then you need to register it in a catalog. And this process is actually staged. You first create a staged area inside the catalog, then you register files that you insert into S3 object storage, and later on you commit a new snapshot with these new files. So this is a pretty complex approach that tools use in order to interact with catalog when they need to write the data. If you think a little bit more, you can realize that there should be some more functionality in order to maintain this system. For example, if you insert the data fast enough, even every several seconds you insert new data, maybe observability. So if you're managing CDN, right, you have observability data that is coming pretty frequently. You want to insert it. Can you insert it in a catalog? You can, but not directly, right? You need some tools. But later on, once you insert the data, you will get more and more files being collected in the catalog. So another function of external system that interacts with catalog is compaction, and this is really, really important. This is the same as merge process in MergeTree. If you insert a lot of things in a MergeTree, then you need to merge, and ClickHouse can do it nicely. Same with catalog, with Iceberg. If you insert a lot of data in an Iceberg as files, you will end up with many files, and they needs to be merged, which is called compaction. So basically, what I'm trying to explain, that catalog is not enough. It's just an interface. You need the system that manages the data for you. And there are such systems like Spark, but it is very heavyweight. Or Snowflake has their own Polaris, which is baked by Snowflake functionality, or some others. And AWS with the S3 table buckets, they did exactly the same. They built a management system, the data management system, which uses S3 as a storage and Iceberg as an interface. And they called it S3 table buckets. So the name is a bit confusing. So it is, in fact, the new system, the new database management system with the existing underlying layer and pretty popular catalog implementation. Of course, we were very interested to try it out because it solves this ingestion problem, because these S3 table buckets, they can compact data automatically, and your number of files don't grow, your query performance is good. So we started integration, I think, in May, and quickly realized that direct integration is not possible. Even though S3 table buckets, they expose REST-compatible Iceberg API, Iceberg REST, it is not fully implemented. There are some limitations of functionality. There is a bit different authentication scheme, which is not supported by ClickHouse, and so on. So what we did, we implemented a proxy inside our IceREST catalog that Robert showed you a bit earlier. And this IceREST catalog is a service, but it can work as a proxy for S3 table bucket as well. So in this case, S3 table bucket provides the actual catalog, but our Ice catalog is a proxy for ClickHouse. And with this deployment scheme, we can read S3 table buckets, we can run queries, and so on. I can show how it works in Altinity Cloud if you're interested. It is very, very easy.
Good. I'll stop my share and you can just demo it.
We have a raised hand, Oliver. You have a question?
Yeah.
Oliver? Yep.
Hello. Can you guys hear me?
Yes.
Yes.
we can.
Okay. I have a questions about the ICE catalog because I am concerning about the moving from Trino to use the ClickHouse to read my Iceberg tables in order to serve and to transform as well. But one thing is that I applied the policy for the catalog to manage who can access the what catalog. But moving on the ClickHouse, I can see that Trino does support the catalog authorizations, but ClickHouse, I'm not sure. So with this approach, ClickHouse via ICE catalog and the proxy, may I able to use the same authorization policy that I have used in the Iceberg catalog before? Thank you.
So if you are using it, do I understand correctly that you currently have Iceberg catalog somewhere? Maybe it's deployed as a part of Trina, maybe it's something separate, and you want to use it with ClickHouse. If this is a question, then of course, yes, ClickHouse can connect to existing Iceberg catalogs. You don't need our Altinity implementation for that. The catalog that we deploy in Altinity Cloud, which is IceREST catalog and the part of Ice project, it is a lightweight catalog implementation for Altinity Cloud and for those users who don't have their own catalog right now. But if you already have data in Trina, you're probably using some catalog already, you can keep using it with ClickHouse, and your authentication model, which is defined on a catalog level, will be applied
Okay,
on
so
backend, not by ClickHouse in this case.
okay. So in my system, I have my own single sign-on approach method for user to sign on, and I can authorize in one place. Can I do it with ClickHouse reading Iceberg table via the Iceberg REST catalog?
Probably not. But what single sign-on system are you using?
I'm using LDAP. Yeah.
LDAP.
Oh.
Okay. ClickHouse supports LDAP, of course, for user authentication and mapping to certain roles. So I assume that it is possible to define a role with ClickHouse with certain permissions and permissions to certain databases and tables. And in this case, you can map your LDAP role to certain user role in ClickHouse, and it will be respected. We haven't tested how it's respected for Iceberg tables, though. Robert, this is something that we need to ask.
Yeah. So if it's so do I understand correctly that this would be a ClickHouse role that we're talking about here, as opposed to trying to
Yes.
link our authorization to, say, underlying
Yes, exactly.
IAM?
Exactly.
Okay, then it works. It works. And this is
okay.
something that's actually really cool, that RBAC, because what's happening, as long as people are touching these files through doing queries on these files through ClickHouse, the permissions get applied at the time that we're actually doing the query planning. So that's done inside ClickHouse. So if you, for example, if you have not granted select on the table, you won't be able to read it. So the user will get blocked. But as soon as you add that user a role that has, say, select, grant select on star.star, or grant select on my database.star, the user will be able to read that, even though it's an Iceberg table, because the gate you're going through the ClickHouse gate, and the RBAC is getting applied by your query initiator. I hope that answers the question. As far as we can tell, this works fully, and I can tell you that actually yesterday I was doing a demo, and I had exactly the opposite case, where I was making new accounts and I screwed up the permissions on them, and I couldn't see my Iceberg tables. So it definitely protects you against even your own mistakes.
Thanks for your suggestions. I think I will give it a try.
Yeah, that sounds great.
Of course, yeah, sure.
Thank you.
Are you in our, if you're in our Slack, you can come ask questions, but this sounds really cool, and we'd love to help with that.
Actually, I've missed the first part of this office hour, but I will get back to after these sessions, and I will post my question on Slack.
You bet. Great. Thank you.
Thank you.
Okay, Robert, could you unshare your screen?
Oh,
please?
am I shared? Just a second. Oh
Yep.
no. Hey, Josh. All right. You guys are gonna think I'm really
It's
stupid.
gonna be, there's gonna be a really tiny little green and red sliver somewhere on your screen.
Oh my God, this thing is.
It's hiding.
Oh, this is.
And we can't see it. Only you can see it. So it's like it's gaslighting you.
Okay. I'm gonna mute before I start ranting.
You
about Zoom.
figured it out, or someone figured it out for you. Maybe it's Kiara.
Yeah.
All right, here we go.
Okay. So this is one of our demo environments with some Antalya stuff, and I am going to show you how we work with S3 table buckets. So we do have catalog already configured, and this is a part of Altinity Cloud, so I can connect to it. And you see that this is the typical REST, but the warehouse is actually not basic, not standard one. You see that this is IRN for S3 tables, which we deployed and provisioned in our account. And we use this catalog, our catalog service, in order to connect to this warehouse. So I'm not going to create the database right now because I already have one. This is the database which connects to 3 table buckets, and I loaded just a single one of the famous open favorite data sets, Bitcoin transactions. Here is, and I loaded it by Ice, by the way. Show create table. So this is a table. You see it is somewhere in Iceberg, and I can run very simple queries on that. So it's just a little bit of data, and I can also show you where the data is actually located, because it's pretty interesting. So you see, this is very long and weird path to real Parquet data, which which AWS servers, it kind of mimics behavior of Iceberg and exposes the data which is stored somewhere inside AWS using Iceberg API. Because we didn't create this path, we just loaded the data into the catalog. Those paths were created automatically by AWS, which is pretty interesting. So what I was going to show you is that we are working on some interesting examples that will show the use of S3 tables. AWS has some interesting data that can be inserted automatically to S3 tables, and in this case, you can consume it and query from ClickHouse using Iceberg. But going forward, as I mentioned, this is very interesting technology that packages all in functionality which you may need in order to store long tail data in AWS as a service, and you can access it from ClickHouse. So maybe Tin, you can also try it out. It is not as cheap as just plain S3. They charge a bit extra for the service itself, but it is really cheap, and you can do compaction in this service automatically using AWS.
Yeah, I can try that, but the instruction is the data is stored in mean. What did you call mean IO?
Minia, okay. That makes things different a bit. Okay.
Right, maybe it's a bit different, but I want to try to connect to real AWS, and I don't know how.
Yeah, sure. That's it about S3 tables. So this is just a pre-announcement. We will have an article coming in the next few days that will advertise this technology. AWS team is very interested in that as well, because this is something new, and they are helping us to get it properly done.
Hey, Sasha, you want to talk about some of the coming attractions, like the ability to vacuum up files off S3 automatically? That's actually a cool feature.
Yeah, so I mentioned that S3 table buckets has a lot of management functionality, like automatic compaction, vacuum, etc. And we're building the same functionality inside our catalog. So this is something new, which is coming next week, I think. And essentially, it will do the following. It will do old snapshots removal. So when you keep changing data in the catalog, every change is a new snapshot. And this snapshot, it has references to the data and data itself. As you get more and more data, new data, those snapshots will keep growing, consuming your disk space. In ClickHouse, you can think of it as inactive parts, right? ClickHouse has a lot of inactive parts which live for 8 minutes, and after 8 minutes, ClickHouse automatically removes that. The catalog by itself doesn't remove this inactive data, and you need a special maintenance process to do it. So we're implementing that as a part of our catalog service. And the second part is compaction. When you have several Parquet files for the same partition, they can be merged together in a single file by the servers. And the third one is probably the most interesting. We are working on automatic snapshotting. So imagine that you insert data in S3, not in a catalog. Your client cannot do any catalog operations. It can only write to S3. But the catalog will discover that there is a new data and automatically register it as a part of your Iceberg table. So that will allow us to do multiple things, including this export functionality that we're talking about. As you may know, ClickHouse can't write to Iceberg catalog right now. This is still coming, but it can write to S3 very efficiently. So what we are doing in order to implement this export partition, export ETL functionality, we will be writing to S3 to the special destination, which will be listed by our catalog and automatically registered as a part of the table.
Yeah, that's going to be pretty cool. And that's coming out this week, right?
Yes, yeah, I hope so. It's Wednesday already, so
Yeah. Well, I hope so too, because I have to show somebody how to use it on Monday.
Oh, okay.
So yeah, and then other things in the next build, there's a bit of a summer gap between builds. We've had people out on vacation and we're doing some refits to the build system, but in the next major release of Antalya, we'll also have a bunch of fixes for glue support. That's something that a lot of people have asked for. We're working on, we have the export, the alter table export that we talked about. That won't be in the next release. I think that'll be maybe in the one after it. And we also have another feature that we're working on, which is to have proper join support inside swarms. That is another one that probably won't get into the first major release build, which is based on ClickHouse 25.6, but it'll come shortly after that one gets out. So, Sasha, can you think of any other cool features that we should let people know about?
Yeah, one more feature that we will add is to get full table introspection in system tables. So right now, if you look into system tables for Iceberg tables, you will only see row counts. But we can actually expose sizes, partitioning, and everything else which is stored in the catalog in system tables, and it will make it much easier to understand what is inside the database. So basically, our goal is to make Iceberg tables to look very similar to MergeTree tables in ClickHouse.
Yeah. In fact, your application shouldn't be able to tell the difference. That's another thing we're working on, is just a bunch of low-level work, which has to do with data type mappings. Like, hey, you have a uint, uint 64, for example, a much-loved data type in ClickHouse. Well, it turns out that Iceberg has int 64. That's a signed int because it comes from Java, and don't get me started about why that's not in Iceberg. But being able to map that correctly to something that will work in Iceberg, and that, for example, you can dump the data out of ClickHouse into Iceberg and have a Python client read it. Getting that mapping, it's essential to get those mappings correct, so that you're generating data that the rest of your clients can read, and so that things like compaction can correctly work because they understand the data they're reading, and indexes correctly work in things like Parquet. So those are also that's also feature work that's going on. These will be trickling into future releases. Josh, what else is on our agenda today?
That's it for the agenda. We only have a few minutes left, so I just want to open up. We've got a few folks in here. If anyone has any specific questions that we didn't answer, it doesn't have to be Antalya related. If you have just general ClickHouse questions or Altinity questions. If not, I have a couple from the community. So we have one question on Reddit that was about moving billions of rows from Postgres to ClickHouse. It seems like the user is moving the data locally to their laptop. So maybe what they want to be doing is is actually not doing that and using like a sync connector or something like that? What are the best ways to move data to Postgres?
Two options. Use the sync connector, which will pull the data from, read the data from Postgres using Debezium and apply it to ClickHouse. The other thing is when I hear people talking about billions of rows, I start thinking, why was it in Postgres to begin with? And so, oh yes, Diego Nieto, Transferia, that's another project. Can we post links? Diego, can you post
Yes,
the links
yes.
on Transferia?
Yeah,
And
we'll
then
do.
sync connector as well. Just post them in the chat. But this question of why was the data in Postgres to begin with? That's an important one because what's happening in some of these cases is there's data which is essentially facts. For example, collected. The worst case is observability data that's being funneled through Postgres. Postgres is just not designed for that, and it kind of clogs it up with a bunch of data, managing a bunch of data that then makes it harder for it to deal with concurrent transactions, which Postgres, of course, is brilliant at, far, far, far better than ClickHouse. So that's definitely something that a question I would be asking about that.
Okay, great answer. Next question, are there any alternatives to the ClickHouse driver for Python for a user working with Airflow and Python and ClickHouse?
Yeah, ClickHouse client. That's the older community driver. It'd be interesting. Do you know why they were asking that question? Was there any context?
They saw something about possible SQL injection vectors using the driver.
Yeah, so
which driver? Because there are two drivers. So there is a
Yeah.
community driver and there is ClickHouse sync driver. They are very different.
Yeah.
ClickHouse Connect is ClickHouse sync driver.
Yeah,
It's
they're using the ClickHouse driver package.
Yeah, the ClickHouse driver is the old one. It uses mainly the native interface, port 9000, and it has limited HTTP
But who
interface.
cares? Who cares?
Can it?
What is SQL injection they're talking about? Is there
Yeah.
a security report about
No
it?
idea. No idea. It's just yeah. Maybe this person, yeah. Don't know.
I know
think
that.
the ClickHouse driver is the old one that I'm still using, right?
Yeah.
Yeah.
The other
It's
and the
Yeah, so
other
are we.
one is support the sync.
Yeah.
it is very reliable, the ClickHouse driver. Yeah.
Right. You have to change the code very big to support
Yeah.
asynchronous operations. That's
Yeah. Both
Yeah.
ClickHouse Connect did that. Yeah, they have like a syncio wrapper and support. They are going to support the new JSON data type, but and ClickHouse driver not. But in terms of reliability, I think ClickHouse driver is good, and you can wrap it
I
around.
use driver on the TCP, not the HTTP. I use a TCP port.
Yeah. But
The other
ClickHouse
one,
Connect is HTTP.
I think the Confluence that support a sync, and it's not very reliable.
Any other questions? If not, we'll wrap things up.
If you have instructions to get me to connect to S3 for the Antalya instead of Minio, I would say that would be good.
What you want is the Antalya examples project. I'm just posting a link that has examples for this. All right.
Thanks, everyone.
Thank you as well.
Thank you.
Hey, thanks, Josh.
Bye.
Bye-bye.
Bye.
Yeah, talk to you
Bye.
soon. Bye.